Connecting scalar and vector projection. Communication question 5. Determine the scalar projection of A on B. Illustrate the projection geometrically. So here we are given two vectors. This is vector A, magnitude 3, making an angle of 120 degrees with vector B of magnitude 4. Now the scalar projection is, so let's say scalar projection, I will represent that vector A, scalar projection on B will be its magnitude, right? That is how I am going to represent scalar projection of A on B. Now scalar projection of A on B is the dot product of vector A with B over the magnitude of B, right? That is how we get scalar projection. And as you know, what is the dot product between A and B? In this case, since we are given the angle, it's better to write this as product of their magnitudes times cosine of angle between them, which is 120 degrees, divided by the magnitude of vector B, right? So that gives us magnitude of A is 3, and then we have 4 here. We get 3, okay, let me write 3 now. Cos of angle between them 120 degrees divided by the magnitude 4. So we get 3 times cos of 120 degrees, which is, let's use the calculator, 120 degrees is minus half, right? You know, so it is minus 1.5, correct? Now, so that is the vector, that is the scalar projection of vector A on vector B. Now the second part of this question is illustrate the projection geometrically. Now here we have vector B and we need to have projection of A on B. That means let's extend B to the negative side, right? And the projection is we have to drop a perpendicular from A onto B. So that will be kind of like this. So this perpendicular, and if that is my point O and this is N, then ON is my scalar projection, right? So geometrically it is ON. Do you see that? ON? So ON is, if you are calling like this, okay, that's fine. It is in the opposite direction, but we are talking about scalar projection, right? So ON is the scalar projection of this vector on B, right? If you see it geometrically, we know, let me use another ink here and show you geometrically how to find it. This angle is 60 degrees, correct? Now, hypotenuse is 3, so what is ON equals to? ON is 3 cos theta, right? Which is 3 times cos of 60 degrees. So we get the same answer, which is 1.5. Now, since it is in opposite direction to the vector B, we'll put negative here. Do you understand why we have put negative? It's negative since it is on this direction, correct? So still, it is indeed a scalar quantity, but our reference point here is this point, which is our 0. Anything to the right of 0 is positive, and anything to the left of 0 is negative. And that is why we are putting negative here, right? It is not based on the direction of B, right? It's based on our origin, O here, okay? Interpret like that. Now, if I say, what is the vector projection of A on B? Well, that is a question for you to answer. So let me know what is the vector projection of vector A on B in this situation. Thank you.